All right, let's get right into it. Today we're looking at a really interesting and kind of controversial theory that tries to crack one of the biggest puzzles in our cosmic neighborhood. What is really making the sun tick? What's behind its powerful, predictable cycles of activity?
So, we've known for a long time that the sun has this rhythm, right? About every 11 years, it goes from being pretty calm to throwing these huge solar tantrums. Now, the official story involves a complex engine, a dynamo, deep inside the sun. But even the experts admit they don't have all the pieces. The source material we're digging into today asks a really bold question. What if we've been looking in completely the wrong place?
Okay, so let's jump in. This theory doesn't start by looking inside the sun. Nope, it starts right here, in our own backyard, with the big guy, the king of the planets.
And here's the first clue. It's so simple it's kind of shocking. On one hand, you've got the sun's cycle, which averages out to about 11 years. On the other, you have Jupiter's orbit, which takes 11.86 years. I mean, look at those numbers. They're almost a perfect match. The author of this theory saw that and basically said, wait a minute, that just can't be a coincidence.
So you have to ask, how could a planet, even one as big as Jupiter, possibly influence the sun? Well, the theory proposes a physical mechanism called charge transference. And let's be super clear here, this is not astrology. This is physics. The basic idea is that the whole solar system acts like a giant electrical circuit. You've got charged particles, the source says they're photons, streaming out from the sun, getting recycled by the planets, and then fed back. It creates this feedback loop that, according to the theory, directly messes with the sun's magnetic field.
But it gets way more interesting, because Jupiter isn't out there dancing alone. The theory pulls in all four of the gas giants. So that's Jupiter, Saturn, Uranus, and Neptune. And it turns out their combined movements create a much deeper, more complex rhythm for the sun. And check this out. Here's another layer to the puzzle. When Jupiter and Saturn line up in the sky, what astronomers call a great conjunction, it happens every 19.5 years. Well, what do you know? It turns out NASA has found a deeper magnetic cycle inside the sun that takes about 19 years. Again, the numbers line up in a way that's pretty hard to ignore.
Now, here's a really crucial detail in how this whole thing is supposed to work. You might think that the planets would only have a big effect when they're all lined up on the same side of the sun, right? In a conjunction. But this model says, nope, an opposition, when they're on opposite sides, works just as well to create a solar peak. Why? Because it's all about the line. Whether they're on the same side or opposite sides, they're creating a straight linear path for that charge feedback to hit the sun with maximum effect.
And this is where the theory serves up a real curveball. I mean, after Jupiter, you'd naturally assume that Saturn, the next biggest and closest gas giant, would be the second in command, right? Well, when the author of our source material actually ran the numbers for this charge model, he had a real eureka moment.
Just look at this table. It's fascinating. The model sets Jupiter's influence as the baseline, a perfect 1.0. But because of how the charge field is supposed to work, distance plays a huge role. And when you factor that in, distant little Neptune actually packs more of a punch than mighty Saturn. That's wild. It makes the most faraway gas giant a secret major player in this whole solar drama. Okay, but the rabbit hole goes deeper. Because this whole planetary dance, it isn't happening in some isolated bubble. The theory proposes that our entire solar system is basically plugged into a massive galactic power grid.
And this piece is absolutely critical. It's not just about the planets lining up with each other. The real key, the thing that determines how strong or weak a solar maximum is going to be, is where that alignment happens. It all depends on how they line up in relation to a powerful stream of charge coming from the direction of the galactic core.
So where is this galactic power line? The source actually pinpoints it. Imagine the solar system as a clock face. This charge stream is coming in from the 8 o'clock position. And how did they figure that out? By working backwards. They looked at the most powerful solar maximum ever recorded, back in 1958, and found that at its peak, the two heavy hitters in this model, Jupiter and Neptune, were aligned and pointing directly at that 8 o'clock spot.
Now, a good theory doesn't just explain the past, it predicts the future. And this one puts its money where its mouth is. The source used this whole model, the gas giants, the galactic core line, to make some very specific predictions for our current solar cycle 25. It pointed to spikes in activity tied to specific events, like the Jupiter-Saturn lineup in late 2020, and the Jupiter-Neptune one in April of 2022.
So, if the gas giants are creating this big, rolling 11-year wave of solar activity, it kind of begs a question, doesn't it? what about all those smaller, spikier moments we see in the solar data? Well, that's where the little guys come into play.
Yeah, if the big guys are running the show, do the rocky inner planets, Mercury, Venus, Earth, and Mars, have any part to play? According to this theory, you bet they do. But their role is very, very different.
Think of it like this. The gas giants are the engine, but the inner planets, they're the turbochargers. They're just too small to drive the main cycle themselves. But when one of them swings around and aligns with that 8 o'clock line from the galactic core, it acts like a focusing lens. It can grab the charge being recycled by the big outer planets and give it a concentrated boost right back at the sun. And that, the theory says, is what causes those short, sharp spikes in solar activity.
So let's pull all these threads together now and look at the huge, unified picture this theory is painting of our solar system's place in the wider galaxy.
Okay, here's the whole shebang, step by step. First, you've got this charge coming from the direction of the galactic core. It gets funneled toward our system. Our sun acts as the central hub, receiving and recycling it. The gas giants, in their orbital dance, create the main feedback loop, which we see as the 11-year solar cycle. And finally, the inner planets jump in to add those little turbo boosts, creating the smaller spikes. It's all one big interconnected system.
But there is one last piece to this epic puzzle. What's doing the funneling? The theory speculates that this galactic charge isn't just flying through empty space, it's being channeled and directed by massive nearby star clusters. And the source even names a prime suspect, a cluster known as IC2602, or the Theta Carina cluster.
And that leaves us with this incredible, mind-bending final thought. What if this theory is right? It completely changes how we see ourselves. It suggests that our solar system isn't some isolated little island in space. Instead, we're a tiny, intricate part of a vast, interconnected galactic circuit, where the very heartbeat of our sun is timed by the dance of its own planets, and the whole system is powered by the stars themselves. Now that is something to think about.